Hello, today we are going to install Fedora KDE Spin in a QEMU Virt Manager virtual machine, and then we're going to install the KDE build system kdesrc-build inside that virtual machine. So this is the Fedora Linux wiki page. I searched for Fedora wiki on Google. So it says 2003, latest version 38. No, the wiki page is old, should be updated. This is the official web page. It uses RPM. It uses DNF, SE Linux, Firewall D. Okay, so Fedora Linux beta released. Okay. Let's try with the latest version because we want to have at least Qt version 6.5 available inside of the virtual machine. If we have inside the virtual machine Qt 6.6, it's even better. So let's see. If we have a spin for KDE, show beta downloads. Okay, so fedoraproject.org/pin/kd/downloads. I enabled the toggle box show beta downloads, and now I have access to the live ISO for Fedora KDE Plasma Desktop version 39, which is in beta currently. For AMD Intel x86-64, AMD 64. Let's download the file. Save. So it's 2.3 gigabytes. And the download speed is really fast. 1 minute left. So let's see a bit about Fedora KDE. So Fedora Workstation is the default spin, the default version of Fedora that end users should install on their desktop. That contains the GNOME desktop, whereas the Fedora KDE Plasma desktop spin contains the KDE Plasma desktop instead of the GNOME desktop, and probably SDDM as the desktop manager instead of GDM. Okay, just a second. Okay, it finished downloading. Let's create a virtual machine. File, new virtual machine. Local ISO, forward, browse. Let's refresh. Fedora KDE. Choose. It automatically selected the correct operating system, and based on that it will select a template for the virtual machine to create. The software virtualization named the virtual machine manager. Forward. Let's make the machine as fast as possible. Let's go with 15. That's 10 gigabytes of RAM. Forward. Let's make this at least 250 gigabytes. The QCOW file, which provides the storage for the virtual machine's hard disk, will be allocated as needed, so it will never take 250 gigabytes in actual size on disk. Okay, Fedora is okay. Customize, the network selection is default. Which network needs to be started? So correct name, latest motherboard BIOS instead of UEFI. This thing is never okay. 1, and this should be 15. Apply. And the rest of the settings are usually okay. So the only thing that I have really changed is in CPUs tab, topology, manually set CPU topology, and I do not have 15 CPUs. I have 15 CPUs cores, which is a different things. Okay. And now we go begin installation. Test this media and start. Okay, let's see how fast the media test is. Pretty fast. Okay, so now it's booting in live CD mode from the ISO file, which is the installer. So this is the live CD mode, starts KDE Plasma Desktop. And in here, we're supposed to click on this icon. I see that it's selection single mouse click mode. So I'll need to press enter or press double click on the icon. Okay, so this is the installer. Let's go with English. English US, continue. Unstable pre-release, I want to proceed. Keyboard English US, make it correct time zone. Root account, disable root account. The wording is not that great when it says that the root account is disabled, because the root account is totally not disabled. It's just that it uses sudo. Okay, so the first user that I create is going to be able to use sudo, require password. Okay. No need to go into advanced. Done. And done again. Network interface, DHCP, network interface card. So that's default. And then hard disk partitioning scheme. Let's see. Okay, select it like this. Not automatic because I'm not sure what's going to do. Not sure what the another option is, because I do not want to use BTRFS, I want to use ext4. I do not want to go through this UI. How do I exit this thing? Okay, custom. So no BTRFS, but a standard partition, whatever that thing is. I need mount points for /boot. No partition for home. How do I make this bigger? available space. Okay, how do we delete the home partition then? Minus. So we have a /boot, which is okay, fine by me. VDA3, which is ext4, which is great. But then I need a way to enlarge this partition. Okay, so 49 gigabytes free. So let's make this 45. Okay, so maybe that's the way to do it. So slash should be ext4, /boot is there. It's going to do probably write the grub bootloader to the MBR. So these settings look okay to me. Done. GPT partition table /boot /ext4 looks okay. Except changes. So that's about it. Begin installation. So I want the virtual machine to be as fast as possible. That's why I've allocated as many vCPUs as possible, -1, to the virtual machine. That's why I've allocated 10 gigabytes of RAM. Maybe more would have been even better. That's why I've allocated 200 gigabytes of SSD and NVMe. And I want the best performance possible. That's why I'm using the defaults, which means network interface card is virt.io, hard disk is virt.io, and I guess that ext4 is a bit faster than BTRFS. And also, I do not know BTRFS. I have never used BTRFS. I do not want any snapshotting features because this is a virtual machine. If I really want to create a snapshot, I'm going to use the snapshot tab in Virt Manager. Okay. Software is installing. I'll pause the recording a bit and I'll be back once it's finished. Okay, so it says that it has completed installing. Finish installation button. I didn't actually read if it requires me to reboot the machine or not. Let's see if restarting like this works. Usually the button to close the installer actually reboots. But now we were booted in live mode, but with a full Plasma desktop, not just an installer. Okay, and now we have booted from the virtual hard disk. There's no ISO inside of the CD-ROM drive anymore. We need to log in order to enable the SSH server or to install it. This is the first time that the user logs in, so many files are created for this user. Okay, let's start the terminal. and see if we can become super user. Yes, we can. Let's see if the SSH server is running. SSHD. Yes. So probably this one, probably installed and probably disabled. So let's enable it. Okay, status. Seems okay. Let's see if we can connect to the virtual machine using SSH. SSH administrator. Yes. And we're inside the virtual machine. Okay. Theoretically, we do not need to use the Virt Manager interface anymore. At least not for connecting to the virtual machine's graphical user interface desktop. So let's log out. Let's close the virtual machine manager. Next up, I want to install a minimum of packages such that I can survive at the command line. So that would be, let's see the man page for DNF. So there is install. It probably does refresh the repository metadata automatically. So let's do that. DNF, install, and the list is Midnight Commander, the text user interface, Orthodox file manager, max minus no x, git. Should be enough for now. Okay, so this is actually refreshing the metadata about the binary package repositories from Fedora 39 beta. Okay. Then this is the list of things that it wants to install and also upgrade. Not sure why it wants to upgrade the CPP, whatever that CP preprocessor, and GCC. That's interesting. And kernel headers. What for? Remax no X or MC for Git. But it's okay. If it installs a C, C++ toolchain, it's okay. We'll need it in a few seconds anyway. This is okay. Any keys are okay. Okay, so while it's doing that, let's look at the way to install the RDP server. Remote desktop protocol, because we want to connect to the graphical user interface of KDE Plasma Desktop inside of the virtual machine. Okay, so Fedora 38. Let's do what it says in here. So install two RPM packages, xrdp and xorg-xrdp. Then we enable the service xrdp. And then we need to look inside of this configuration file, which is wrong. So the configuration file should totally be updated by Fedora to be correct. At least in Fedora 38, I needed to edit it by hand, but hopefully it's fixed in this version. Let's pause the notifications. How do we do that? 4 hours. Okay. So Emacs. And towards the end, there's the section xorg. This one. So it's still commented out, which is a bug. Control XS, Control XC. So I have uncommented the entire section xorg, and now I need to reboot. Let's see the virtual machine starting. Let's see if we can connect using the SSH server. We can. And let's see if we can connect to the RDP server. I'm using the xFreeRDP, FreeRDP, RDP client because I'm on X11, not on Wayland. There's another executable for Wayland, which is WL FreeRDP. Okay, so this is the command line. I need to open a new tab in console, Ctrl-Shift-T, paste, and the IP address ends with 24. Okay, do I want to trust this SSL certificate? Yes. Okay, what did I do wrong here? Xorg, administrator. Okay, maybe it's very obvious what I did wrong. Okay, so I'll debug this issue a bit and I'll be back once I find a solution. Okay, so I was too enthusiastic while I uncommented out the lines and I deleted characters. So just following the procedure, uncomment all of the lines in here should be okay, but I've uncommented them wrongly. Okay, so not sure what this code thing is. Port, IP, password, username, lib. Where are you? Code 20, yes. Lib and name. So this should be it. Let's reboot again. Okay, so we managed to install Fedora 39 Beta KDE spin. We have a virtual machine. We have the KDE Plasma desktop. We could connect to the virtual machine using the RDP protocol. The next step is I will start recording just the interior of the FreeRDP window. Just a second. So now we're connected to the virtual machine using the RDP protocol. This is the screen recording of just the interior of the virtual machine. Next step is to set up the KDE build system, which is called kdesrc-build. For that, I'm going to use the web browser to read the instructions. Just a second, let me customize this thing. Okay, so I'm done with customizing Firefox. I'm going to use a private window. On the right half of the screen, I will have the documentation. On the left half of the screen, I will have a terminal. Okay, so kde.org. The homepage of the KDE community, hamburger menu, get involved. Ways to contribute, development. So it says that a better supported operating system by the build framework kdesrc-build are Arch Linux OpenSUSE Tumbleweed KDE Neon and the latest version of Fedora KDE. Hopefully it works. We'll see what's the version of Qt available on Fedora. How do we do that? Fedora package search Qt6, something like that. So Fedora 39 has 6.5, which is okay for kdesrc-build. So both Fedora 38, Fedora 39, and Fedora Rawhide have versions that are okay for development with kdesrc-build. People probably by default install the release version, the latest release version of Fedora, which is Fedora 38. I went with Fedora 39 because it's going to be released in pretty soon. Okay. Fedora Rawhide is a rolling release, rough around the edges version of Fedora. So we have the needed requirements, and now let's set up kdesrc-build. On Fedora it says that I should run this thing, which so I've already installed Git. Let's see if these packages are really needed. We're not going to set up Git because we do not want to write to the KDE Git repositories. We just want to read. And then we're going to git clone the KDE Git repository for kdesrc-build. And in there's two Python, two Perl executable files. One is kdesrc-build, the other is kdesrc-run, which we're going to run. Okay. Now we're going to run one of the two executables, kdesrc-build. So executables are these ones in green with the X bit flag set. So there's run and there's build. Okay. So it complains about not having enough Perl. Says something about Perl IPC. So probably we'll need to run this command line. Okay, so it installs a ton of Perl RPMs, which is okay. We're not bloating the system by installing RPMs from the repositories from the Linux operating system that we're using. Yeah, setting up kdesrc-build will install way more than 4,000 RPMs on our system, but that's not a problem. They can always be uninstalled if you don't like them. But they will not conflict with each other. They are tested. They are just pieces that fit perfectly inside of Fedora. So not a problem if we install many RPM packages. It's not going to degrade our system in any way. Okay, so back to running the command line that has failed. So it's installing more than 700 packages. So first of all, it's downloading all of them. 711 packages. So there's many devel packages because KDE, Git repositories, are written in C++, so that will require C++ and C development RPMs in order to use the libraries that exist on the Linux operating system on Fedora. You can see things like Qt6 something and then devel. This one. And this one, etc. So it both installs many RPMs that contain libraries, but then it also installs RPM packages which contain the .h include headers for that library. Okay, so it finished downloading. Now it's going to install all of these packages. Okay, so we'll pause a bit because there's a bit of progress to do. Okay, so it finished installing the packages, the RPM packages. Now it has created a configuration file, this one, /config/kdesrc-build and with an rc at the end. I do not want to have any enhancements to my shell, so I go with a default option where it says, should I update the bash rc? I go no, so press enter. Okay, so I'm not customizing my Z shell, I'm not customizing my bash, I'm not customizing my fish shell. Okay, setting up Qt, so it says that I should have at least Qt6.5, which I do. I can see it in here, it says Qt6 6.6, wow. Okay, then it says that I should do something such that the directory where kdesrc-build is going to work, which is /kd, is not subject to continuous reads and writes from antivirus software, from security software from disk indexers, etc. Okay, so says system settings, workspace, this thing, and then search, and then file search, and then I should add an exception for the directory ~kd, which I'm not going to do. It's a virtual machine. I don't have any important documentation here, documents here. I do not want to have indexing inside of the file content, so I'm going to disable the file search altogether, apply, delete index data. Okay. And now the next step would be to reboot my computer in order for the changes to bash to be applied. I didn't apply any changes to bash, so I do not need to reboot anything. Okay. Now I'm going to start compiling. I always compile the same things using kdesrc-build just to make sure that kdesrc-build installation is correct. Okay, first of all, I'm going to need Kate. Where are you? No. Where? Okay. Sudo su dnf install Kate. Is this okay? Yes, it is. Let's see what software is installed in here. So I have kwrite instead of Kate, so I've just installed Kate. I'm going to actually remove kwrite. So dnf remove kwrite. Yes, it's okay. Okay, let's find Kate. Let's make it favorite. Okay. So the order I do it is because I didn't change bash in any way, the environment variable path has not been changed. The binaries are inside of this directory. So the two binaries being kdesrc-build and kdesrc-run are inside of this directory ~kd/src/kdesrc-build. This directory is not part of the path environment variable, so the way in Linux to run these two executables is to actually change into this directory and then go /kdsrc-build and /kdsrc-run. So that's before running any kdsrc-build commands, you're going to change to this directory. I'm with the wrong user. Okay. And then you're going to run / and kdsrc-build or /kdsrc-run. That's the way I do it. I change to this directory and then I run / kdsrc-build. I do not find any advantage in having the path environment variable changed. Maybe I want to have more than one installation of kdsrc-build. It's just okay for me. As a bit of a twist, I'm going to move the configuration file to the same directory, so to ~kd/src/kdsrc-build, from where kdsrc-build --initial setup creates the file. So from tilde /.config/kdesrc-build-rc. Okay. And before actually running any command, I'm going to actually look inside of this file and see if it's okay. Okay, so defaults, which are okay. This I changed to debug if I'm going to use a debugger, or I'm going to use an integrated development environment. This I'm going to increase from 4 to 14 to make the compilation speed faster. And the rest of the things are okay. The rest of the defaults are okay. So in fact, I've only changed num cores. So I've incremented this from 4 to 14. See that the num cores is correlated with RAM usage. So if you don't have enough RAM usage, enough RAM in the virtual machine, if you have only, I don't know, 4 gigabytes of RAM, but you have 14 vCPUs in the virtual machine, maybe you want to allocate less than 14 cores for kdesrc-build in order not to have your compiles fail. So you will search a number between 4 and 14 that works on your case. But for me, with 10 gigabytes of RAM, I know that 14 works. Okay. The very first thing that I'm going to run is kdesrc-build and a KDE Git repository that depends on just one other KDE Git repository, which is kconfig. So kdesrc-build does 3 things. As the command line parameter -" initial setup, which installs the needed packages from your Linux operating system on your computer such that you can compile KDE frameworks version 5 and KDE frameworks version 6 correctly using kdesrc-build. Then it has the functionality where when you say kdesrc-build and then the name of a KDE Git repository, it knows where that KDE Git repository is stored. So it's invent.kde.org/framework/kconfig in the case of kconfig. It knows how to git clone it, which is this thing. It knows which branch to use, which is the master branch. And it knows all of the dependencies of the KDE Git repository kconfig, that dependencies that are needed in order to build or run, so build dependencies or run dependencies of kconfig. Those build dependencies might be KDE Git repositories or might be other Git repositories that are not part of the KDE community but do use Qt. Whereas Qt is taken from the Linux operating system. So we have installed Qt correctly, Qt6.6, many RPMs, which are libraries which have nothing to do with Qt, but then all of the libraries that sit between Qt and KDE are going to be built from source using kdesrc-build, such as GPGME, for instance. Okay, and the last functionality, the third functionality of kdesrc-build is to build a module correctly. So building a module correctly means doing git operations, so git clone in this case, and then later on it updates your source code tree using git, so it does git fetch master, git rebase, git stash, etc. Then it knows how to run the step which is called configure cmake, then the step which is called compiling or make or ninja, and then the step install, which might be make install or ninja install, and then there's a final step which is not shown in here, which is running the tests, so make test or ninja test, but that requires a special command line parameter for kdesrc-build, which is --run -tests. Okay, so 3 functionality known by kdesrc-build: how to set up your computer by installing RPM packages, what are the dependencies between KDE Git repositories, and how to build one Git repository if the previous ones have been built correctly. Okay. So kconfig depends only on extra CMake modules, ECM. In order to find out the dependency, the fact that kconfig depends on extra CMake modules, it needed to git clone another KDE Git repository, which is this one, sysadmin repo metadata, where there's text files where it says kconfig depends on extra CMake modules. The best branch for kconfig for Qt6 is called master. So let's look at how these things look on the hard disk. So kdesrc-build installation resides inside of just one directory, which is /kd, does not exit this directory. It installs in here, it builds in here, it git clones in here, everything happens in here in /kd. Your computers, your system remains untouched, pristine. You just have to delete the /kd directory, and it's like forgetting that you have ever used kdesrc-build. So it doesn't mess your system at all. And then inside of the KDE /kd directory, there's 3 subdirectories, which have been configured in the configuration file. One is where make install does its thing. One is where kdesrc-build does git clone operations. And another one is for building build artifacts, generated files, CMake output, etc., which is the build directory. Okay, so it all started in the src directory. We created the directory kdesrc-build. We git cloned in here. So this is a Git repository. We git clone in here a Git repository. So git remote -v. You can see it's a Git repository. This is the origin remote. Okay. And then we needed sysadmin repo metadata. This is another KDE Git repository, was git cloned in here. Then we needed to git clone and do all of the needed operations on the KDE Git repository extra CMake modules, which was git cloned in here, was built in here. These are built artifacts, intermediate files, files generated by the step CMake configure, Ninja configuration files. Okay. And then the last step, this step, is installing, which takes file from the build directory and puts them into /kd/usr, which directory has a similar structure to what you know in a Linux operating system to be under /usr. So there's a bin directory with executables, and then there's so files that have the cc-elf, the 4cc, which is elf executable files. Okay, then there's .h files in the /kd/usr/include directory, and share other files, so themes, images, CSS files, etc. Okay, so we kdesrc-build git clones in here, builds in here, and then makes install in here. Okay, so it git clone the KDE Git repository kconfig. It has built it into /kd/build/kconfig. and then the build artifacts that were created in tilde/kd/build/kconfig/bin directory by the step installing, which does ninja install, has copied these files into tilde/kd/usr/lib64 in my case on Fedora. So this is a kconfig shared library. KF6 means KDE Framework 6. Okay, we can see more verbose debug output. So let's go with --debug to see what's happening. And where are you? And in case nothing works and you want to do a very clean rebuild, because kdesrc-build does by default incremental builds as fast as possible, does not do rebuilds. If you want to rebuild, a way to do it is to use the refresh build command line parameter. Another way to do it is to clean up the directories. So there's no reason to clean up the tilde/kd/src directory, because this is managed by Git. It's just a Git checkout, nothing else. But you can delete the entire build directory and the entire USR directory without any problems. Okay. Let's look at what it actually does. So it did a ton of things. So this is the CMake configuration step, where it says which dependencies have been found and which have not been found. In order to run the CMake configure step, a number of environment variables have been set in order to prefer the directory tilde/kd to other directories from the system. This creates ninja files, and then it runs ninja -j14, which means build the software using the ninja files that were created by the CMake configure step. Okay. So these are git operations. First time it does git clone, and the second time you run kdesrc-build, it does other git operations. Does git, what? Git stash, git fetch, the normal things to do. Okay, and then it builds the modules in order. First it built extra CMake modules, then kconfig. And for the module kconfig, you can see where it starts doing things on the module. So after it does make install extra CMake modules, it starts with kconfig. First it does git operations, then it does CMake configure, so sets environment variables, then calls this long command line. This is the output from the step CMake configure. Then it has created ninja files, which are similar to make files. Then it runs the compiling step, which sets environment variables, changes to this directory, and runs the command ninja -j14, which builds all of the C++ translation units using 14 CPU cores for speed. Okay, so there's 435 C++ translation units, builds all of them, then links them. In here, does the linking, so the executable files and SO files are created correctly in here. And then Ninja files have been generated. It's going to run the installing part, which sets some environment variables, then runs the command line ninja install, which, as you saw, takes files from tilde/kd/build/kconfig/bin and puts them into tilde/kd/usr/lib64, the SO files, and then the .h files puts them in tilde/kd/usr/include. SO files, .h files, SO files, .h files. And then these are translations. The files with extension QM go into tilde/kd/usr/share because they're not SO files and they're not executables. And that's it. Now we have built the KDE framework version 6 kconfig correctly. Next thing that I run is a GUI application, which is the desktop calculator, which is this application. Okay. The command line is kdesrc-build and then the name of the KDE Git repository, which is kcalc, with a / in front. This will build 22 Git repositories. The vast majority are from the KDE community, but then Wayland is not from the KDE community. Okay, so Wayland has not built correctly. And now, when one of the 22 modules fails to build, kdesrc-build will stop there. And we'll see why it didn't build. Because there's no expat. Okay. We have documented this thing, hopefully. So these things. Let's run them. And install some more. And now we try again. So kdesrc-build kcalc was the command line. We want to build the KDE Git repository kcalc that contains an executable applications graphical user interface that's a desktop calculator. Okay, so this is going to take a while. It's very fast on one machine. It's going to take, I don't know, 2 minutes or something. We'll pause a bit and I'll be back. Okay, so it finished building kcalc, 22 Git repositories. Next up is to run the executable. So that's kdesrc-run kcalc. Why do we need a complicated way to run kcalc? Because this kcalc comes from tilde/kd/usr/bin, which is not part of the environment variable path. If this executable needs additional data, it will maybe not be able to find its SO files, its shared directory, its Qt plugins, its QML dependencies, etc. So that's what kdesrc-build-run does, sets some environment variables and then calls the correct kcalc from the correct directory. Okay, so this is the kcalc that we have built using kdesrc-build from the KDE Git repository straight from the master branch. And this is the kcalc that comes with the Linux operating system. It's the same application, but this is wider by default. And then in help about kcalc, you can see that the versions are different. So the version of the application is different. The version of the KDE frameworks is different. So this is KDE frameworks 5.109, whereas this one is KDE frameworks 6 with version 5.240. So a version that's very close to 255. 5.255. And then Qt is 5.15.11 for the kcalc that comes from the operating system, whereas the kcalc that we have built from source using kdesrc-build uses the latest released version of Qt, which is 6.6.0. Okay, and then kcalc built from source is not using the correct theme, whereas the kcalc installed from the Linux distribution actually does respect the correct theme. The scroll bars are different, the tabs are different. Without theming, you can see the accelerator in the main menu, so this underscore. Whereas with the correct theming, you need to press the Alt key to show the accelerators. So I press the Alt key, I release the Alt key. Okay. And then these are totally different themes. These fonts are bold in the tab title, whereas these are not. The buttons look different. The size of buttons is different, so everything is different. In order to fix this thing, what you want to do is to build the KDE Git repository named Plasma Integration. Okay. And then when you run kdesrc-run kcalc again, kcalc will be able to use the correct theme. Okay. I want to make sure that kdesrc-build has been set up correctly. For that, I'm going to try to build all of the KDE frameworks version 6, which is this command line. Let's run it. 86 KDE Git repositories and Git repositories that are not from the KDE community, such as Wayland protocols. Wayland. Some of these KDE Git repositories have already been built as part of building kcalc. So we have built 21 Git repositories except the Git repository for kcalc when we went kdesrc-build kcalc. So some Git repositories are really fast to build because we're not rebuilding, we're just building. We do incremental builds. If all of the files have already been compiled correctly, the compiling step will be really fast. Whereas some other Git repositories have not even been Git cloned. So first it Git clones the Git repository and then it builds. Then it runs the rest of the steps after Git clone. So configure cmake, compiling, which is Ninja, and then installing, which is Ninja install. I'll be back once it finishes building. Okay, so it stopped midway at building Git repository 39 out of 86, could not build a non-KDE Git repository, which is Poplar, which is a PDF rendering engine. Let's see what it wants. No test data found. Says could not find NSS 3, which is the Netscape security SSL sockets layers library. Let's actually try to do what it says in the possible solution. We're on a Fedora system, so we should use sudo dnf build deb, and then the name of the package, which is Poplar. Let's see what it suggests. So it says we should install NSS devel, exactly as it says in here. So let me just install this package and see if it's enough. You should press yes in here and install all of the dependencies of Poplar, and that's it. And it's also updating all of the other dependencies because the Fedora repository updates testing is enabled. Is this okay? I'm going to go with no, just to see if just installing this package is enough. Ctrl-Shift-T, sudo su dnf install NSS devel. I go yes this time. And now back to the tab 1. I try to build KDE frameworks again, but it will say that 80 Git repositories are to build. It will go fast through the first 39, but then it will do a cmake configure and build for Poplar. So we do not want to do an incremental build for these 38 Git repositories. We want the building to resume from Poplar because we know that the previous 38 Git repositories have been built correctly. So we want to resume from. -- help. Resume from equals and then the name of the module. -- resume from equals. Okay, so it found all of the dependencies because it's starting the building. Okay, I'll pause again and I'll be back if one module fails to build or if the building all of the KDE frameworks version 6 finishes successfully. Okay, so now another Git repository has failed to build, which is called upstream, where it says that the package config file gi.docgen or the cmake file gi.docgen could not be found. And this is a GTK GNOME technology. They do not use CMake, so there's a missing package config file with this name. So the name of the file is gi-docgen.pc, most probably. How we fix that? In DNF, there's support for specifying a package not by RPM package name, but by this thing, package config, parentheses, and then the name of the package config. So I issue the command dnf provides package config gi-docgen, set that the name of the package is gi-docgen. So at this point I can install it, so I can go sudo dnf install gi-docgen, or I can be even bolder and go sudo dnf install and then package config parentheses gi-docgen closed parentheses, which says that it's going to install gi-docgen and it's the RPM named gi-docgen and its dependencies. And I'm okay with that. Okay, and now I need to run the kdesrc-build command line again, but this time I'm not going to resume from the Git repository Poplar, but from the Git repository that has failed, which is this one, upstream. Okay. Okay, it finished the CMake configure step, so it found all of its dependencies. Upstream does not use. It has a configure step, but not using CMake. Okay, and now we have 40 more Git repositories to build. I'll be back. Okay, so all of the KDE frameworks have built successfully. The last step to do, which is very optional, is to build Plasma integration and then run kcalc again to see that the correct theming is applied to the application.